Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, the first thing you want to do is to remove your greatest common factor, which on this one is a 3y. And so when you do that, you're left with 343x cubed plus 8y cubed. And so we're going to use our formula for a cubed plus b cubed, which is a plus b, a squared minus ab plus b squared. So you're going to have 3y, and then the cube root of 343 is 7x plus 2y, and then 49x squared minus 14xy plus 4y squared. And so all of that would be your answer for your factoring. Okay, for the math knowledge question, we're just going to factor this. It says which of them is a factor. So x minus 2 is a factor, x minus 4 is a factor. The only one they give you is x minus 4. So that's your answer for that one. So we're looking at lesson 45 today. We're going to use f prime to characterize f, and f prime to find our max and mins. So hopefully you'll be able to understand how you use your derivative to characterize your original, and using the derivative to find max and mins. So your function is increasing when for every f of x1, if that's less than f of x2, whenever x1 is less than x2. So as your x values get bigger, your function values should get bigger. That's an increasing function. And then likewise, it's going to be decreasing if for every bigger x value, there's a typo here. This should be a less than. If for every bigger x2 value, your function keeps getting smaller. Okay. So if your derivative is greater than 0 for every value of x on an interval, then that means it has to be an increasing function. So if your derivative is always greater than 0, then it's increasing. And if your derivative is less than 0 for every value on your interval, then it's a decreasing function. If your derivative is greater than 0, then it's increasing. We just said that. If it's less than 0, then it is decreasing. If it equals 0, then that means it's a constant function. So y'all can write that however you want, but that's what's going to be important here. This is the graph of our function f. We want to know where the derivative is going to be positive. So our derivative is our slope. So at what of the points is the slope positive? Well, at A, the slope is positive because it's going up. At B, it's going down, so it's not a positive slope. At C, it is positive because it's going up. And then at D, it's negative because it's going down. So the derivative appears to be positive at A and C. If you have a function such that the derivative is greater than 0 for all of your x, then describe the graph of f. Sketch how f could possibly look. So if it is positive always, that means that our function f must have a positive slope for all values of x. It means it is increasing for all x values, basically. So one easy one would be a line that's always going up. This one would be another one. Here's another one. There's another one. It just said sketch. You could have just done one of those, but any of those would work. Okay, shown is the graph of some quadratic function f. We want to sketch the graph of the derivative. So we're sketching basically what the slope looks like. From here down to our vertex, the slope is negative. So that means that our derivative is going to have to be below the x-axis to show that it's negative. And then at 1, it's going to hit the x-axis because the slope is 0. So the x-axis is where it equals 0. And then from here on, it's positive because it's increasing. So it's going to be above the x-axis. And so that's how you sketch the graph of your derivative. You're just looking at your slope. Looking at this next one, they're giving you information about your derivative, and then we want to sketch the graph of f based on the derivative. So we can start with zero. We're going from 1 and 2 for our x values. So I'll draw on my graph. We're going 1 and 2. And it tells us the slope when we are before 1, when we're less than 1, it is less than 0. So that means it's negative. So if our slope is negative, our function is going to be starting up here and then going down. Okay, that's all we know when it's less than 1. When it's at 1, it equals 0. So that means that, like if it was a parabola, it would come to a point here. We're not really sure yet, though, what happens from here. Okay, so in between 1 and 2, it tells us the slope is greater than 0. So that means that it's going to be increasing if it's positive. So it's starting to go back up. Increasing, increasing. And then at 2, it equals 0. So we can put another dot at 2. And then when it's greater than 2, the slope is back to decreasing. And so that's how you would graph your f function based on your information about your slope. Okay, so they give us the graph of the derivative, and we want to sketch the graph of our original. So they gave us our slope. So the slope is positive here, and the slope is positive here. Here, it's negative because it's below the x-axis. So for f, we're going to be increasing until we get to this point here at negative 2. And then from negative 2 to 4, we're going to start decreasing. But then when we get to 4, we're going to start increasing again. Now, the graph that I just drew that's black, I can get it to select it. For some reason I can't. You can make it go any direction you want it to, up or down. So I'll just graph another one. It could be down here. We don't know exactly where it is on the y-axis. We just know that it hits a maximum at negative 2 and it hits a minimum at 4, basically. That's all we know. So you can have it graphed anywhere on the y-axis. That's not true, going back to this one, because they gave us the original and we graphed the derivative. So we know that since this is a 0, that it has to cross at that axis, at the x-axis. But this parabola could have been pushed up here with the vertex still at 1, and it would still produce the same derivative. So f has a little bit of leeway where you can graph it on your graph, like a vertical shift, but f prime, you have to have it pretty exact where it crosses the x-axis. Okay, so using our derivative to find our max and mins. If your slope is positive just to the left of an x1 and the negative just to the right of x1, then it's a local max. And if it's negative to the left and positive to the right, then it's a local min. And so that would be if you have 0 slope. This is where if it's positive to the left and then it's negative to the right, that's where you have a max. And then if it's negative to the left and positive to the right, then this is a minimum. And we've talked about max and mins a little bit in the past, but that's just a little bit more on them. Your slope is going to be increasing and then all of a sudden it starts decreasing. Or it's decreasing and then all of a sudden it starts increasing. That's where you have your max and mins. So looking at an example, suppose our function is a function such that the derivative at 1 is 0. It's positive on the interval from -3 to 1, and it's negative on the interval from 1 to 4. Sketch the graph of f near 1 and indicate any special characteristics of f. So this is our x-axis. And we're really concerned about 1. They gave us -3 and they gave us 4. So it's not drawn to scale necessarily, which is okay. So they tell us that the slope at 1 is 0. So that means that there's a dot, and it could be doing this or it could be doing that. We're not sure yet. The slope is positive from -3 to 1. So that means it's increasing. And then it's negative from 1 to 4. So that means that it is decreasing. So there's our graph. And the characteristic of f at 1 is a maximum. And that's your answer. You have what looks like to be a parabola where 1 is your maximum. Okay, let's look at another one. Use the first derivative to demonstrate that it attains a relative minimum at x equals -1. So we need to find our derivative first. And that would be 2x plus 2. So if we set it equal to 0, that would give us -1. So that means that -1 is a critical number. And then if we look at this, this is a parabola. And so our critical number is -1, so that means that it's going to be a relative minimum there. And so that's all it's asking me really to do on that one. They don't really ask you to do those much. Use the first derivative to demonstrate it. That's more just trying to get you to think about how they work. But that's basically what you would do. Okay, so on your homework you do get to omit number 24. Make sure to do the other ones tonight so you can go over any questions you have tomorrow.